Hello everyone, myself and Arun Kumar from SNS College of Technology in the Department of ECE. In this video, I am going to share about don't care condition in minimization techniques and logic gates. So understanding the designer challenges, it is comes under empathy part because the don't care is the term which is represented as X, and moreover the X term is used to refer either 0 or 1 based on the input and output conditions. So here the example given as BCD to 7 segment decoder. So in this case, how the X has been utilized and how the value has been mapped with the help of some logic gates. So here the problem is if you are placing either 0 or 1, then the logic gate translate directly to the increased power consumption, and it makes that higher manufacturing cost, and it requires large number of board areas, and moreover the final product is very competitive one. So in order to avoid this, we can use the term X is used to refer for both the gates. So define. So initially the don't care has represented as X. So X is nothing but it may be either 0 or 1. So based on the requirement of the input and output conditions, it may be placed. So here let us see the example of a table. ABCD is the input signals. Then how these signal has been mapped. So here X indicates about X indicate about either it may be 0 condition or 1 condition. So here the mapping is done with the help of X, because the possible combination of X denotes that it may be used for 1 conditions, so that it can able to map with the help of other adjacent cells. So here we see that X11 is marked as all those columns, and X1 is marked as remaining terms. So here X1 and 1 1. So already we have discussed about the K maps. So in that the possible combination has been marked. So here X is the term which is used as 0 or 1. So based on the requirement of the signals, so that it can be mapped along with the adjacent signals. Identifying the don't care. So in this case we are going to verify the truth tables with the help of this don't care condition. So let us see the consider of example binary coded decimal converter. So here the possible combination has been written as A, B, C, D input signals. After that it has to be converted from decimal to binary signals. Binary coded decimal signals, so that we can able to verify the table by using zeros and ones. So here the output X is indicates about so the possible combination of X to be marked as 0 or 1 in the respective tables. Next one is optimizing with don't care conditions. So here the optimizing table conditions has represented by 1. So here the marked the X value is 1. So the green is indicate about 1. So the green is nothing but 1 1 1 1. So the 4 combination has been marked as green color, and it indicated about F1. And purple color is F2. The purple is nothing but 1 1. So here the only the adjacent values with respect to the table is 1 1. So that I am just making as 1 1 as the my next consideration value, and next one is orange. So here if 1 1, so if the 1 1 is present opposite value means, then we have to mark it as 1 1. So the final value of the 1 1 has been determined with the help of A, B bar, C bar and B C bar. So the final answer is A dash, B dash. So the common term of B dash C and B C dash is C dash. So the final answer is A dash and C dash. Like this, the value will be comes under this X value. Next one is the example of 4 variable structure. So here they are given about the minterm condition as input signals. So here I am going to mark it as all those value in the table. Let us see, the table becomes 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 like this. So based on the K map values, and we are going to mark it here as X value, so based on the D value. So here the don't care condition they are given in the question as 10, 13 and 14. So the likewise the values of 3 is to be marked in the table as 10, 13 and 14. So next we have to check the adjacent value of the cell. If it is 1 or 0, then the possible combination need to be verified. If it is mapping is mapping, if the mapping has to be done, means then we can able to use this x value, or else we can neglect or ignore the value. So here we see this 1 1 and x. So here we need to check the possible combination. Yes, there may be some possible chances of marking x along with the neighboring cell 1, so that we can use this x value. And next 1x. So here we are the combination of 1 and x term, so that we can mark it as this value, and we can able to verify this 1x with neighboring cell. So yes, this is the possible combination, so we can able to mark it this value. So after marked all those value and the combination has been done by using the final formula as bd dash plus b dash c. So this is the final equation of this Boolean expressions. And next is validating and refining the model. So here the model has been done with the help of min term, and here is max term. So min term is nothing but one value has been marked as usual the K-map formula, whereas 0 is to be marked as max term. So max term also we are using 0. So here the x value is to be marked based on the adjacent cell. If there is any possible combination of mapping, so we can use this x to the neighboring cell, so that we can able to verify the table by applying the K-map rules. Activity, the activity given as think pair share activity. So initial question given as K-map simplification using don't care conditions. The phase 1 is to be done think for 5 minutes, and phase 2 is pair for 10 minutes, and the phase 3 share for 10 minutes. So along this we can able to know the particular concept of the K-map simplifications by using the don't care conditions. Assessments. The cells marked with X in the K-map represent invalid inputs, don't care conditions, logic 0 only, output errors. The answer is don't care conditions. And next one is don't care conditions are used to increase the number of variables, simplify the Boolean functions wherever the beneficial, remove all the minterms, convert SOP to POS. The answer is simplify the Boolean function wherever the possible, whenever and wherever the possible, we can use this term. Mind mapping. By using this mind mapping, we can able to know the particular concept of the don't care condition, so that we can able to know about the status and their corresponding terms. These are the reference I have taken for this video. Thank you.